Hello and welcome to today's webinar on SICAM EGS. So what's EGS? Enhanced Grid Sensor. And what's it useful for? Well, to get information and definitely more transparency in your local low voltage power grid. I am Michaela. I will guide you through this webinar, and if you want me to, I'll be your voice. Well, how that? We plan a question and answer round at the end of the session. And we cannot hear you, but we can read your messages. So everything you place in the upper right corner into the question to the speaker field, I will read and I bring your question to the experts. If you place it in the chat, we will also find it. And the easiest way to get it to the speaker is the question to the speaker chat. No, question to the speaker sending. So I told you I will bring your question to the experts. And who are our experts today? Well, with me in the studio is my dear colleague Gerhard Schubert. Gerhard, welcome. Gerhard is definitely an experienced technical sales support, and well, he doesn't know everything around power management system, but a lot, definitely deep know-how there. I think you will hear that again during the presentation. He knows what he's talking about. And the round would not be complete without my other colleague, dear Anis Ben Abdeljalil. Hi Anis, welcome on the stage. Anis is also an experienced technical sales consultant, and his deep know-how is, well, focusing not exclusively, but on substation automation system. So you see that both experts really fit into get information on low voltage power grids with the SICAM EGS, our enhanced grid sensor. And now let's go into details. Gerhard, the stage is yours.
Thank you. Thank you, Michaela, for this introduction. Also, good morning from my side. As Michaela mentioned before, my name is Gerhard Schubert. Like my colleague Anis, I'm working as a technical sales consultant and promoter with Siemens SIE in Germany. Today, we are going to talk about a new solution that will help operators of low voltage distribution grids to increase the reliability of the networks. Please, Anis.
Thank you, Gerhard. Hello, everyone. Good morning from my side. This presentation will be divided into the following 4 sections. We are pretty sure that most of you already know the purposes and challenges of low voltage transformers, distribution stations, and low voltage distribution grids. But for those of you that are new to this topic, we would like to spend a short time providing some background information. During the second section, we would like to give you some important information about the SICAM EGS for designing your individual solution. Then, in the third section, we will also give you an impression of the engineering process. Finally, before coming to our Q&A session, we will close the presentation with a short summary. To warm up, let's begin with a basic look at the purposes of a low voltage distribution substation. Apart from supplying energy to the end customer, according to our point of view, there are the following 2 additional purposes. One major goal of the low voltage distribution grids is to keep the voltage for end users here in Central Europe as close as possible to 230 volt AC. Maybe you know that there is a 2009 agreement not to deviate more than 10% from this nominal value. However, with low voltage cables, you cannot bridge long distances. As a rule of thumb, in urban areas, you can bridge about 300 meters, and in rural areas, about 2 kilometers. In other words, for such distances, you need a low voltage substation to keep the voltage at the nominal value. And the second reason is in low voltage distribution grids, imbalances and harmonics can occur. By considering suitable transformers in the low voltage station, for example, a transformer with special windings, such negative impacts can be mitigated for the medium voltage network. At this point, please let me bring you back to the frame conditions that were common for low voltage distribution grids some years ago. Since there were no photovoltaic installations, there was only the power flow direction from the grid to the consumer. Private customers neither had big loads nor did they generate significant harmonics. At that time, even without permanent monitoring of the low voltage information, it was easy for the grid operators to run their low voltage networks. This was the reason why they didn't usually invest in installing sensors. But today, at least here in Europe, the situation has completely changed. For example, connected photovoltaic systems can reverse the power flow. On the other hand, new consumers like e-cars, heat pumps, and air conditioning systems can cause an overload in the power network. Since inverters and rectifiers are also involved, there is a risk that undetected harmonics reduce the lifespan of the low voltage transformers. But the biggest challenge is that most low voltage distribution grids are still not monitored. Hence, for the time being, many grid operators don't know if there are any problems in their grid. As mentioned before, typical low voltage transformers mitigate the negative impacts on the medium voltage network. This means that only monitoring the medium voltage will not help you to detect possible challenges on the low voltage side. Please also keep in mind that the primary equipment of the low voltage distribution grids usually has a lifespan from 30 to 50 years. This means that many of these power grids are based on primary equipment that have been selected according to obsolete load profiles. With this slide, I'm finishing the background information section. As you can see in this picture, forced by the need for transparency, some low voltage grid operators already started to create their own individual solutions. They took different devices like RTUs, modems, meters, sensor, and other material to configure a system. However, it is more than clear that such a solution is complicated, expensive, needs a lot of space, and needs a long time for commissioning. This was the initial point where we from Siemens recognized that there is a need for innovation to find a better solution. So, Gerhard, please, the stage is yours.
Okay, good. Now that you know our motivation, we come to the second part of this presentation, which deals with our solution to gain the required transparency in the low voltage distribution grid. All mentioned devices, you remember RTUs, switches, sensors, all these devices are combined in this single compact device. As you can see, the name of this new product is SICAM EGS, where the abbreviation EGS stands for Enhanced Grid Sensor. Not to start the development of this device right from scratch, we based the controller inside on our already available CP8050 controller and adapted it to the needs of this application. This approach brings following advantages to the customer. first of all. Already approved technology is available for his project. Second advantage, all the standard features like communication protocols and all these things of the product platform are also available in SICAM EGS. And third, SICAM EGS uses the same engineering tool like other SICAM controllers. Means that we from Siemens can provide a homogeneous solution starting at the low voltage and going up to the highest voltage levels. As far as I know, we are the only one who can provide such a solution, by the way. But let's treat now all the other provided features and the characteristics of our solution on the following slides. I would like to start with a very basic topic. It's the installation of our device. Here, the following typical requirements in low voltage substations must be taken into account. Most of these substations and cable cabinets are very small and they do not offer much space for any additional installations. Second, there you will neither find heating or any air conditioning systems. Then, to provide fast commissioning times, any changes of the existing installation must be avoided. During the development of SICAM EGS, all these challenges were, of course, considered. As shown, the device is so small that without any modification of the existing installation, you will find a place to install it. We recommend mounting it in horizontal position, but actually there aren't any restrictions. It does not look very nice, but even an installation upside down would be possible. Depending on the needs of your project, there are several solutions to mount the device. As listed on this slide, you can screw it with 2 screws to a wall, or via 2 magnets, you can fix it on metal. By using a third-party adapter, even an installation on a DIN rail is possible. As mentioned before, low-voltage substations have harsh climatic conditions. To overcome this challenge, SICAM EGS has an operating range from -20 to +70 degrees Celsius, and it was designed to feature IP54. At the top left of the device, you can see a small plastic lid, which is secured with a screw. Behind the lid, there are 2 interfaces. To keep IP54, even when using these interfaces, we developed a very sophisticated solution. 2 round cutouts are already prepared in the lid. If you want to use an interface, then you just have to press on the prepared cutout. By considering the suggested connector with integrated sealing, IP54 still can be achieved. For the acquisition of currents, SICAM EGS provides 3 Rogowski coils. Also, depending on the project, SICAM EGS comes with 2 different versions. One version with 1 meter cable length to the Rogowski coils, and a second version with 3 meter lengths. For both versions, the coil diameter of the Rogowski coil is 70 centimeters. In case that you want to install the Rogowski coils over a bar, then the coils can be slightly squeezed. Good. Now that we have solved the basic challenge of installation, let's come to the main task of the device. It's the permanent acquisition of analog information. To measure the current on the secondary side of the low voltage transformer or at the main feeder with an accuracy class of 0.5, the 3 Rogowski coils are already fixed to the device and calibrated. Currents up to 1000 ampere with an overrange of up to 2000 ampere can be measured with this solution. The SICAM EGS also comes with 3-phase voltage inputs. Via these wires, the nominal voltage of 230 volt AC can be measured with an accuracy class of 1. To make the installation in a project easier, the wires L1 and N also serve as power supply input to the device. In case that the incomer has tripped, some customers still need to get the last valid information before the failure. To cover this requirement, SICAM EGS can also feature as an option a so-called last gasp capacitor. As a minimum, this capacitor is able to buffer the device for 1 minute. Please kindly note that using this option limits the upper operating range of the device to plus 50 degrees Celsius. A lot of additional information is also calculated from this measured information, which I will show on the next slides. Good, just a moment. Yeah. We will not go through all the shown details of the slide. The message that we want to convey to you with this slide is that SICAM EGS offers a lot of miscellaneous information. At the start of a project, it is up to the project engineer to select the considered information for the transmission to other systems. Just to explain the basic principle of the elaborated information. Most information is available in 2 versions. One version only considers the fundamental oscillation of 50 Hertz. The second type of measured values shows the true RMS, including harmonics up to the 25th. What are now the benefits of the provided information? This is really important. The grid operator will recognize whether the transformer is operating at its limit. By the sign of the active power, a possible change of the power flow direction is also indicated. By monitoring the value of the total harmonic distortion, possible harmonics that could reduce the lifespan of the transformer are signalized. And last but not least, also deviations from the nominal voltage are indicated. To avoid any misunderstanding, all shown information is elaborated from the analog information that is retrieved by the device itself. Means that by only installing a SICAM EGS, the grid operator gets a lot of useful information. But our solution goes one step beyond. If you also want transparency about the outgoing low voltage feeders, then there's a sophisticated solution that is depicted now on the next slide. Good. Most of the low voltage stations here in Europe are using NH fuses. Our colleagues from the Siemens EP department developed a smart fuse that combines following functions. First of all, it features a compatible NH2 fuse with GG characteristic, a current measurement function that measures the current through the fuse with 1% accuracy, an integrated temperature sensor that measures the temperature at the shaft of the fuse, a secured radio transmission using the communication protocol ZigBee. And finally, it also features a built-in power supply that uses the current through the fuse. Since most of the voltage distribution stations are using the version NH2, for the time being, our colleagues from Siemens EP focused on this type, but later also versions for NH1 and NH3 will follow. The SICAM EGS features a built-in ZigBee modem that can communicate with up to 48 of these NH3NA fuses. Means that in total the SICAM EGS also will be able to deal with the data of 16 outgoing low voltage feeders. What are now really the main advantages of this entire solution? Even without any modification of the existing installation, you get the required information. And the replacement of these fuses can be done within very, very short time. And there is no need for additional cables or any current transformers. Like for the SICAM EGS. I do not want to confuse you with all the shown details of the measured acquisition of the 3NA COM solution. Since this presentation is recorded, you later have the possibility to check the shown details by yourself. But the key message that are important for most of the projects are, as long as a minimum of 2 amperes are running through the fuse, it has the capability to send the available information in a cyclic time of 2 seconds to the SICAM EGS. For the current and the temperature time, time windows to create average values can be configured. For the time being, such devices are available for nominal currents between 80 to 350 ampere, but in a later step, this range will be extended. In case that a fuse is blown, it is sufficient only to replace the upper part of this module. To point out, the communication part still can be reused. Good, Hannes, please could you continue?
Thank you, Gerhard. So far, we have only spoken about the local function of the SICAM EGS. Now, let's focus on its communication features. We already mentioned at the beginning of this session that since SICAM EGS is a member of our product platform SICAM 8, all the standard communication protocols of this platform are available. Examples of these protocols are IEC 104, IEC 103, IEC 61850, Modbus, MQTT, and many others. Using these communication features, SICAM EGS becomes very flexible. Via the serial interface, you can connect different local devices, such as medium voltage sensors, meters, or medium voltage short circuit indicators, and protection relays. A typical use case of the network interface is the connection of a classical SCADA system. Since the SICAM EGS also features an integrated LTE Category 1 modem, encrypted data can be exchanged with a cloud system without installing external modems. As you can see on this picture, SICAM EGS also offers a built-in web server for HMI functionalities. What does it mean and why is it important? Using this function, you can connect locally or via a network to any device that features a browser with HTML5 compatibility. For instance, with the help of this function, predefined HMI pictures of a standard substation can be displayed. This feature enables a commissioning engineer to test the correct acquisition of the local data without involving any SCADA or cloud system. We would like to show you the configuration of 2 typical use cases. Here on this slide, you see the system architecture of our solution for a cable cabinet. The picture shows the acquisition function of analog information. This acquisition is done via the Rogowski coils and voltage inputs. Data from the 3NA fuses is retrieved via the SIGP protocol. Depending on the customer requirements, available data can be forwarded to the SCADA and or cloud systems via the network or LTE interface. As you can see in this configuration, we show a typical low voltage distribution substation. In addition to the previous configuration, information can be exchanged with devices on medium voltage level. For example, short circuit indicators via the serial interface. Please note that this illustration does not show all the other standard features that are also provided by SICAM EGS. I just want to name 3 of these functions as examples. For exchanging data between connected devices and the SCADA system, SICAM EGS can also work as a full-blown RTU. In the configuration shown, this example would mean that data coming from the devices on medium voltage can be forwarded via the SICAM EGS to other devices. Another example is that SICAM EGS features user-definable logics according to the IEC 61131-3 for adding automation functions. Customers having low voltage transformers with tap changer positions can use this automation feature to generate step commands based on the voltage measurements. And as a third example of the standard features provided, I would like to highlight the cybersecurity functions implemented. An example use case of this function is the possible automatic update of certificates according to the norm IEC 62351-9. Coming back to the example configuration, there is no need to start a project with a complete architecture as shown. This means that low voltage feeders or connections to other devices can easily be added in a later step. The last slide of the second section deals with the SICAM EGS capability to communicate to cloud systems. Why is this topic important for low voltage applications? The answer to this question is simple. If you imagine that some low voltage distribution grid operators own several hundreds of low voltage substations, then you can also imagine that classic SCADA systems can be overloaded by the large amount of data. Our suitable Siemens cloud solution is called SICAM Navigator. It not only offers very flexible user-definable graphics, but also features a lot of functions to recognize and analyze possible problems in the low voltage distribution grid. However, SICAM EGS not only works with this proprietary cloud solution via the MQTT communication protocol, other cloud systems can also be connected. Depending on the need of the project, selected data or all data of SICAM EGS can be transmitted. According to the needs of your project, you can select between spontaneous or cyclic data transmission. When using cyclic transmission, the required cycle time can be configured. So, Gerhard, the stage is yours.
Thank you, Hannes. Oh, good. Now we come to the basic engineering process. At the beginning of the third part of our presentation, I would like to explain the philosophy behind our engineering solution. Most of the customers who are interested in SICAM EGS are already using other SICAM devices at higher voltage levels. Even if a new customer only wants to install SICAM EGS now, we are convinced that later system extensions will follow. To make the engineering process easier for these users, we have integrated SICAM EGS in our comprehensive standard engineering tool. It is the SICAM Device Manager. On the other hand, we know that especially for low voltage stations, short engineering and commissioning times are essential. This is the reason why we recommend performing following main engineering steps. First, start to create a project template by entering all data that is equal to all low voltage stations. Just to give you an example of such data, for example, the publisher ID of the cloud application will be the same for all stations. In the second step, enter few individual parameters for the individual station. This step either can be prepared in the office or at the beginning of the commissioning phase on site. After loading the individual parameters into the device, you will be able to check the correct function of the installation by communicating to the integrated web HMI. Yeah, at this phase of our presentation, I've prepared something for you. I hope you can see it. That's normally the moment where the music starts to play. I'm pretty sure you're very curious to see the device in reality. That's the SICAM EGS. And by the way, my hands are not so big. It's a device that is so small. You can see it here. Why we explained it? Why is this so important? Because in distribution panels or the cabinets or existing stations, you will not have much place. So that's this compact device. As mentioned before, you could install it like this, or even like this. Then how to mount it? We already explained it. For instance, here you can see a hole, also here a second hole. By 2 screws, you could fix it to a backplane. Or you could even fix it by magnets using these 2 holes. Before this session here, one of my colleagues had asked me if I also will open the device. No, I will not open it because this device features IP54. So, and by the way, we are using inside printed circuit boards with SMD technology. So it's not possible, or it's not required to open it. Good. Then we also explained it before. I put it now here on the table. Here you can see the 3 already attached Rogowski coils. Very important for you is, you can see here the diameter is 7 centimeters. One of my customers has asked me, he has a copper bar coming from the low voltage transformer. And he told me that maybe 7 centimeters could be at the limit. As explained before, you can also slightly squeeze it. Okay, and of course, you can open it. Good. Then, we explained it before. The Rogowski coils are already, I should put it this way, the Rogowski coils are already attached to the device. It's not possible to detach it. Why not? Because this is to increase the accuracy of the device. We have already calibrated them. Good. Then the next topic, we also explained it. Here are the 4 wires for the voltage input. As you can see, it's approximately 1 meter length for it. This device, as I have it here, is normally used for cable cabinets where the distance to the primary feeder or to the in feeder is not so long. But as explained before, also this cable length or wire length to the Rogowski coils is also available with 3 meters, especially if you have, for instance, a low voltage station with a low voltage transformer. Yeah, and coming now to, not to forget, here you see the plastic lid. If I would press now here, you don't see it, but these are cutouts here and here. if I would press here now, then there would be this plastic could be removed, and behind this plastic you will find a network interface and a serial interface. If a customer only buys this device together with this one here, maybe you have seen the title slide of our presentation. It was a customer in a pilot project. He only bought this device. Using this compact device features already that you can permanently monitor the output of a low voltage transformer or an in-feeder. And via the built-in LTE modem, this customer transmitted this information to a SCADA system. So only by this brings a lot of advantages. But I also explained it before, our solution goes one step beyond. And now we are coming to the 3NA smart fuse. This is the real fuse part. As you can see, it's compatible to an NH2 version. And here comes really the highlight. I can put this communication part here on the shaft. And this small communication part is powered by the current running through the shaft. As long, I told it, as long as 2 ampere are running through the shaft, here we have energy, we call it energy harvesting. So inside this communication part is powered. It features the ZigBee protocol, which communicates to this device. And up to 48 of this device can communicate to the SICAM EGS. In addition, you also get via this communication part the temperature of the shaft. So the operator can know, is the fuse already, from the temperature, is it already operating at its limit or not? Of course, we're also transmitting the current to the EGS. So both values are available as the actual value, and also we can transmit an average value. It depends on the configuration. Good. Then, yeah, one colleague also has asked me, what happens if the fuse is blown? He also explained it. No problem. You just take the fuse, you replace this part. This still can be reused, and you put it to the new fuse. That's it. Okay. Then, maybe I should also, let's come also to the details. Maybe some of you have noticed that here there are 2 LEDs, here and here. One of them is the ready LED. As long as the microprocessor inside is running, the ready LED is on. Then you also have an error LED. Normally, you never should see it. When could it be that the error LED appears, especially if a communication to a SCADA system or to a fuse is broken? Then the error LED will come. And finally, maybe you see it, here's the push button. It's a reset button. Depending on the duration, you press the reset button, you can reset the device, or you can reset to the factory settings. Frankly speaking, between you and me, we would not need this button, but some customers had the wish for such a feature. The wish of a customer is our command. Yeah, then I think that's the most important things to explain with the EGS. Good. Maybe honest. Let's put it here so you can see it. Honest, please, can you continue?
So, thank you, Gerhard. So, let's continue. This is the end of our presentation. So let's have a short summary. It is easy to install SICAM EGS because of its small dimensions. Installations can be done within a short time because you don't need to change the wiring of your existing substation. Using project templates, you get a flexible solution with short engineering and commissioning time. Since SICAM EGS features the same standard characteristics as the SICAM 8 product platform, you get a secure and reliable solution. As mentioned in the previous slides, SICAM EGS is an all-in-one device that provides a very economical solution. SICAM EGS will come in two versions. One version with a cable length of 1 meter to the Rygowski coils, and the second version with a cable length of 3 meters to the Rygowski coils, plus last gasp function. With this statement, I would like to close the presentation and start the Q&A session.
Thank you, Anis. And thank you, Gerhard. Well, that was interesting stuff around this, well, small but really valuable hardware. I just had this on Hanover Fairground to present during the tour, and a lot of people were impressed how easy to get insights in the grid, because that's, yeah, we had been blind. But let's see what kind of drives you around, what you want to know. Questions are there. I will read them, you will answer them, and you have still the chance to place your question in the tool. We definitely have some time today reserved just for answering your questions around the SICAM EGS. Somebody talking or wants to know around communication. There's an integrated LTE modem inside. Can this be used also for other protocols?
Okay. The answer is clear, yes. Also TCP/IP-based protocol can be used for sure. Yeah.
Perfect, thanks. And yeah, a question of timing. I don't know if you've mentioned that during the presentation, but when will the device be available for projects?
Sure. Okay. We will start, or most likely we will start the sales or the sales release of the device in October. Means that the device for you as a customer will be available in the first quarter of 2024.
All right, thank you. That's right behind after Christmas, right? Kind of. And yeah, you mentioned 50 hertz. Is the device also available for 60 hertz power grids?
Yeah. At the moment, only 50 hertz, and 60 hertz is in the roadmap.
And planning, yeah. Go one step after the other and not all at the same time. I think it makes the development definitely more reliable.
And maybe if I may add, why we started with 50 hertz. Maybe, because of this energy crisis with fossil energy and with Ukraine crisis, energy prices here in Europe are very high. That's the reason why a lot of people are installing PV panels here in Europe. And also they are shifting from standard cars now to e-cars. Mm-hmm. And therefore, especially here in Europe, there was the strong need for more transparency on low voltage grids. As far at least as I know, in other countries, like in the US market with 60 hertz, or other countries in Asia, the energy prices are not so high. And therefore, according to my understanding, maybe the low voltage grids work a little bit different. Maybe at the moment, they do not have these challenges. This was the reason why we started with 50 hertz, but as my colleague mentioned, 60 hertz is on the roadmap.
Mm-hmm. So focusing on the critical countries, in this case, 50 hertz countries, and that'll be extended. Thank you. And then what is the application used for industrial automation installation? Will it help industry customers?
Let's say the main focus is on utility, low voltage distribution grids. Nevertheless, if you have in an industrial application low voltage cable cabinets or in-feeders that you permanently want to monitor, using the Rogowski coils and also this feature is also possible. And as my colleague mentioned, this is a full-blown RTU or controller. So, of course, I'm pretty sure even in industrial application, you can use it. Okay.
Depends on what you want to see in your grid.
Yeah.
Thanks. And then the question came in via the chat from SFA. Does the EGS have a compatibility? Good morning, no coffee, huh? A compatibility with SICAM or SAT RTUs? I mean, I think the question came in before you presented the communication protocols.
Okay, probably, yeah.
Yeah.
I already mentioned that the
Yeah.
SICAM EGS is a member of SICAM 8. Also, SICAM EGS is based on CP8050 hardware. And we use the same configuration tool. We have the same protocol. It means it's a part of the A8000 product portfolio.
So it's definitely
for sure it's compatible in these cases.
Yeah, talking loads of protocols, if I remember that correctly.
Yeah, of course. For instance, as mentioned before, if you press here, you get a serial protocol, or here a network protocol. So by, for example, using IC104 or IC101, of course, you can connect it to, here we're talking about SAT, the old SCD devices. You could communicate with an AK, all these devices. 3 times, yes, is the answer.
Perfect. And what just comes to my mind, sometimes they change protocols. So if I now have a configuration with a serial communication and press this one, then I have a hole in the box. And if I then need to change or want to change to a Ethernet-based protocol, I need this hole. Can this stay open or should I replace the lid?
That depends on your climatic conditions.
Oh, okay.
If you have, for instance, high humidity, then I would recommend to renew this lid. And by the way, I was deeply surprised. I went to the development department. We are talking just about the plastic lid. But even for such a small part, there's so much know-how implemented. I was really, the developer talked maybe 15 minutes about designing it because it must be hermetic. It must be really sealed. And if you get the device, just open it, look at it, you will see the shape, how it is done. It's really sophisticated. I was really impressed by it.
Cool.
Okay.
And that's just the lid. I think the sophisticated stuff is also in there, right? Thanks. So, the next question from THL that also came in before you presented the box, because THL wants to know analog hardware signals wired to the SICAM EGS are mentioned. That was in the presentation. Which type and how many analog inputs does the SICAM EGS support? And then also around so it's milliamperes, that's, we see them here, or PT100. So what's on it? Can we repeat that?
I think the question is already
it was answered, right? Maybe a bit different, right?
Okay. So you were talking about milliamperes. There is no milliampere input, but again, if by using these interfaces, there are so many devices that you can connect, for instance, using Modbus RTU, Modbus TCP/IP. So via these interfaces, you can connect them. And the number of analog inputs, this is a full-blown RTU. I repeat it again. I'm pretty sure you will never reach the limit in a substation. Okay, I hope this answer helps you.
But the wired inputs, they are limited because they are calibrated,
just
right?
a moment. This is for 230 volt AC, and this is for, let's say, the connection to of real currents starting from several amperes going up to 1,000 ampere. So we are not talking about milliampere.
Better
Okay.
not.
Yeah.
All right, thank you. I hope that answered the question. And if not, you might already know if your question, or if you feel that the question was not fully understood, if you want a more comprehensive answer, contact the experts directly. You have the contact data on the web page. You will see the contact data in the presentation that's available for download. And yeah, just go to them, ask them directly. No problem. I'm sure you will answer, right?
For sure.
So, and then the question that came in from BR, why IEC 60870 and not IEC 61850?
I already mentioned in the presentation, we support both.
Okay. It's not a no.
61850 also supported server and client.
So in the question, we just delete the not. So it is 608070 and 61850.
Exactly, yes.
If I may add, at the same time, for instance, using IEC 68070/4/101, you could transmit using the LT modem to a SCADA system. And on the other side, using this interface here, this wired interface, using IEC 6150 to communicate to protection relays. And please allow me to comment, as far as I know, we are the only one who can do this for this voltage level.
Impressive. And then THL, engineering. Yeah, question from engineers. Yeah, and from the engineering, the parameterization job. Typically, a customer has thousands of devices. Well, then, will we have thousands of SICAM EGS? How to deploy all these devices based on zero or low touch deployment? Oh, yes, really. How do I get them in parameterization? Well, I need to physically attach them, right? No chance to get rid of that. But talking about the parameterization, is there any kind of typicals I can use?
Of course. Yes, of course, I agree with you. Normally, customers have between 50, maybe not 1,000, but hundreds of these devices. Yeah, and therefore, as mentioned before, you can configure these devices in the office. You can already load it into the device using the device manager, or you can create, for instance, a template, and on-site, because it's only a few numbers of parameters that have to be adapted to the needs of the individual substation. For instance, the substation name, the number of feeders.
Sure.
So these things, you can also do this in the office or at the beginning of the commissioning on site, and using the device manager, you can download it into the device. Yeah, and as my colleague mentioned, without any touching or very few steps have to be done on site, especially, for instance, wiring this, connecting this on site. And if we are talking only about this device, then these steps also can be done under while the end users are connected.
Ah. So I can still operate, no interruption.
As long as we are talking about this device, yes.
Yeah, I mean, yeah, if I want to attach something to a fuse, no chance to make it if it's under current. Yeah, definitely. Brings us to the next question from KC. What is the smart fuse rating range? I think you mentioned something like this. Well, the fuse itself?
82,350. But other versions we have on the roadmap. I think they're coming next year.
Will follow. Yeah. And I think it's detailed in the presentation.
I think so, yes.
Yeah, so
we mentioned it.
I think I might have mentioned it already. You can download and read.
And yeah, by the way, also if you need more details, our colleagues from Siemens EP, if you search in the internet using Google, for instance, and if you type in 3na.com, then you will find all the available ratings of this.
Oh, cool. Yeah, that's 3NA, that's the type of the fuse, and then
Exactly.
COM for communication. Really sophisticated naming, yeah. Thank you. So, oh yeah, somebody who knows about power quality. CF wants to know, with the EGS supporting IC 61850, I guess there's an integration of power quality applications, something like PQS and PQA. So power quality, I don't know S anymore, and power quality analyzer.
At the moment, not, but we have it on a roadmap, let's say.
Okay. Already in planning. Yeah, we just mentioned it. One step after the other instead of going.
But
right.
nevertheless, for the harmonics,
already mentioned that, yeah.
THD is available.
Mm-hmm.
And why is it so important? Sorry, I have to repeat it. We mentioned it. Normally, such low voltage transformers have a lifespan between 20, 30, or 50 years. If you have harmonics, then the lifespan could be significantly reduced. And that's the reason why we have implemented the THD factor. Good.
Yeah, and reduce the lifespan always means you need to take money and order in advance. And
yeah, if you consider that a customer maybe has hundreds of such low voltage substations, it's very expensive.
That's
and
true.
We support up to 25 harmonics.
Up to the 25th harmonic.
25th harmonic.
So it also helps with sustainability, because I can make use of my transformer even longer. Okay, next question. Thanks for the ones so far. Casey wanted to know, what is fail-safe powering battery? Well, do we have a battery? I don't.
The last gas
capacitor.
It's a capacitor, right?
It's
No battery.
It's a capacitor.
Yeah.
This version here is without capacitor. I did not show. If we have the version with the capacitor, I think it's 1 millimeter, a little bit bigger. Inside, then here would be the capacitor. And the task of it is, imagine that you have a cut in the power supply. The transformer feeder, for instance, trips. Many customers are interested to get the last valid values before and after the trip. And therefore, we have this capacitor, which is able to power at least this device for 1 minute. Okay.
That's quite some time, right? To
it's
with
enough,
this before and after.
It's enough time.
Yeah.
It's enough time. Yes.
Thanks. Good. Yeah. And why not a battery? Because I would have to exchange it.
Very good question. Why not a battery? We want to reduce, let's say, the maintenance and service activity of the customer. If we would install now a battery inside, then maybe after 5 years, maybe after 10 years, all these devices have to be opened and replaced. That's what we
want
to
IP54
also this topic.
Right?
This is what we want to avoid, and that's the reason why we have inside a capacitor.
All right, thank you. And then THL wants to know, is the ZigBee, so what we use for the smart fuses protocol, in the SICAM EGS already included in the first rollout, or will it be included in 20? Yeah, you mentioned it. It will be there, right?
It's very important for us to connect the fuses, and it will be included in the first release.
I do not know THL. Maybe he asked this question because what we did during the development process, of course, we wanted also to get the expectations of the customer, also feedback of the customers. So we had a pilot phase, and selected customers have already used this device. And in the first version, the ZigBee protocol was not included. Maybe that's why THL, sorry, I don't know your name, has asked this question. But again, in the final version coming at the beginning of next year, the ZigBee protocol, which will be able to communicate with up to 48 smart fuses, will be inside. Good.
Quite a nice amount of information sources, right?
If you imagine that in a feeder you have 3 of these fuses, then you will be able to communicate to 16 low voltage feeders.
Yeah, that's
Yeah.
quite an amount
48 users.
instead
Yeah.
of blind flight.
Exactly.
Yeah. Great. So this is kind of a prototype, right?
Yes.
We're really not brand new, but already in action at pilot customers. Got information there. I like that. Great to have it here. Next question from SFA. I think we almost already answered, because does EGS have embedded module to support IEC 61850 protocol, or does any additional module need to be there? Needs to be the interface to support this in the substation? It's just included, right?
It's
all in.
No additional modules.
No
Kind of
additional-
all inclusive.
Yeah.
No additional costs, it's included.
And we speak here, as I already mentioned, is similar to CP 8050. It means if we have TCP/IP interfaces, it can be used for different TCP/IP protocols.
Mhm.
So no need to one protocol assigned to one physical interfaces.
Cool.
Mm-hmm.
With one physical interfaces, we can assign different TCP/IP-based communication protocols.
And maybe just one additional statement to your previous statement. This, yes, it's a prototype, because my colleague just had it in his office. But we are, let's say, the real development is already finished. We are passing the last tests, but it's already finished. So we are sure that at the beginning of next year, it will be available for you.
Yeah, all these certifications with IP and testing and something.
Exactly, yeah.
Need some time. Next one from DV. How will you define ESG in a few EGS, I'd say. EGS in a few words.
Wow.
Well, let's see.
That's a challenge.
Try. So enhanced grid sensors, and that allows for insights into your low voltage grid where we didn't have any information before. And so, yeah, it brings eyes into your grid, right? And now it's yours to enhance that a bit. That were really few words. Well, depends on how many words you allow us for.
Yeah, and the challenge is, as mentioned before, some customers just use this device, some customers use it in combination with this. Other customers use it in combination, these two devices, together with medium voltage devices like protection relays, short circuit indicators. So it's very flexible. That's really the challenge. It's a full-blown. It's a permanent grid sensor, and on the other side, it's a full-blown substation RTU and controller. Maybe, but you have followed our conversation. This question is really a challenge.
It is, but in really few words, it's a brilliant box. Maybe go like this. And next one, KOC wants to have a physical training. You want to touch, right? That's my advantage here. I can. Is it possible? And it's really welcome if I can come over for a physical training. Do you need a physical? Well, you mentioned device manager. There we have trainings, right?
Probably in the future we can organize a training, but at the moment the device is not released.
At the moment it's not released, and what we also have planned, if a customer has maybe thousands or maybe hundreds of these devices, what we also plan is to provide videos explaining, for instance, the configuration. Also to reduce the task on the required procedures on your side, on the customer side.
So no traveling somewhere, and the advantage of a video is that I can replay and check what did they do there. But will we offer physical trainings? Not sure on that, right?
At the moment it's not settled, but take care.
Well, stay tuned in the Power Academy.
Yeah. As long as we are only talking about this device, I'm pretty sure it's not settled, but I'm pretty sure that the videos will be sufficient. At the moment that you connect other devices and you use it in addition as an RTU, then maybe such trainings will be required. Okay.
And then the question from SS, I think it was also mentioned in the presentation, but we'll nevertheless focus on that. Can the SICAM EGS connect to a SCADA system using DNP? And I think I've seen it on the list,
yes,
right?
Yes,
Yeah,
yes.
I think it was
They
there.
support DNP, TCP IP, no? If I'm not, yeah.
DNP3 IP,
DNP3
yes, and
IP,
it can be connected via the LAN interface here or via the LTE modem.
Ah, okay. Thanks.
But take care, DNP, as far as I know, mainly is used in the US market. Once again, at the moment, we do not have 60 hertz, but it is on the roadmap. If you talk about, for instance, Poland, according to my experience, also in Poland, DNP3 is used. Then we have replied to this question.
No problems there, will be supported or is supported.
Yeah.
And oh, interesting. BB wants to know, can a customer build the same application with a CP8050 or a CP8031 by adding AI modules? Well, I guess the functionality can be built, but
this functionality could be built,
but not with this protection class and not with this compact size.
And especially with this one here, then he needs an additional adapter. I would not recommend it, because then you lose all the features that we have explained before.
And then you need to take care if your configuration is secure. I mean, I think you started with a picture. I remember customers started in putting things here and there, and well, a lot of hardware, and then it's all in one responsible.
I have just to mention that this is not a standard RTU. Okay, we have all functionalities of the RTU, but the device itself is designed for medium voltage, low voltage distribution substation, and especially for the acquisition of the low voltage bus bar, or the transformer output. It means this device is designed specially for these applications.
And up to now, we haven't spoken about the price, and I will not speak about the price, but it will, I promise you, it will be a very economical solution. And especially if you consider this one here just has to be replaced by the existing fuse. So no wiring changes, no testing of the wiring. Also, this is one aspect for cost reduction, which you have to consider. If you talk now about a CP8050, which does not feature a built-in Zigbee protocol, maybe you lose this advantage. Okay, good.
And then SB wants to know, where's the slot for the SIM card? Because I saw the LTE modem equipped.
Yeah. May I? Sorry that I'm talking all the time. As mentioned before, this at the moment is just a prototype. I only had this one here available. My colleague brought this with me. In the real type, then here is also a second lid, also made of plastic. Here you can put in the customer, not Siemens. You can put in the SIM card. So, and again, as mentioned here, also this lid will be very sophisticated to keep IP54.
Sealed again, right?
Yeah, of course.
So yes. I open it, put in the card, close it, and then I keep my IP54.
Yeah.
All right, thank you. So, and then WM wanted to know, is the device applicable to 25 kilovolt AC applications? Well, that's not low voltage, medium I'd say. That's medium voltage.
So it's a full-blown RTU. As mentioned before, if you do not want to use the disadvantages with the low, especially these disadvantages, then via these two interfaces, you could connect medium voltage devices. But
short circuit indicators and example, so we can receive the voltages and currents from the medium voltage via the connection.
Exactly.
So use it for low voltage insights and add some information from medium voltage.
That's typical for IMUs, for instance. That's a typical use case. But if sorry, I don't have spectacles.
No, it's WM. Gerhard only copied it from the chat into our questions.
Sorry, I'm blind. Okay. if WM only wants to use it for medium voltage, then I would recommend to use our controllers like the CP8031 or CP8050.
So the standard A8000.
Exactly.
Stay within the SICAM world. So, and EMU wants to know, is it possible how to get this video for more understanding? This video, the recording of this webinar, yes, you will get access to that. It will be, the reminder to the recording will be sent out to you from the system. And you will get access to even more information because my two experts will receive homework. They will answer all the questions in a written manner, and you will receive that information too. And if you talk about this video for more understanding on the installation and configuration, they are on the road, right? They are not yet prepared, yeah, but they will be available. Mm-hmm. Well, I guess stay tuned on our channels there. I hope that that answers your question. And then I see currently one last question that came in from THL. There are customers who have several parallel cables. So like 240 square millimeters per phase on low voltage horns, even up to 7 cables. How do we solve this with the supplied Rogowski coils?
Really,
I mean, in case on 7, yeah?
I think...
No,
he's
talking about this. Let's say we talked to customers and they had up to 4 cables. And for 4 cables, this is suitable. To answer your question, please allow me to answer you in a written version, because I have to talk to the development.
All right. Okay. Yeah, 7 sounds much, yeah? Like something like this, yeah?
I know an application where they have up to 4 cables, but...
Yeah, you clarify that. So I already mentioned the written answers. Currently, I do not see any more questions from you. Thank you for the questions you've sent in. You will receive written answers. If questions come to your mind later, do not hesitate, contact the 2 experts. And if you contact me, I will forward the question, but the faster way is to get directly in contact with them. Yes, I already mentioned you will get access to the presentation. You will get access to the recording. I hope you stay tuned with the electrification and automation webinars. There's more to come. And for now, I wish to you keep yourself and your systems protected, and see you in one of the next webinars. Goodbye.
Goodbye.
Thank you. Bye.